Alright, in this video I'm going to be talking about cipher modes, and this is referring to modes or methods of configuration that all ciphers work with large data streams without the risk of compromising the provided security. Now we have ECB, also known as electronic code block. In this mode, every block is separated or is separately encrypted, but it uses the same key to encrypt each block. So there's an issue with this. The issue is that if information repeats itself, so as you take each little word and you encrypt it with the same encryption key, you're going to see a pattern. So for example, the word "the" is a common word, and each time it is encrypted, it will produce the same ciphertext. So an attacker could actually possibly figure that out. Now we have cipher block chaining, CBC. To avoid repeating ciphertext, CBC uses an IV, an initialization vector that is XOR'd, or it's called exclusive OR, with the block of information, and that outcome is encrypted with a key. The outcome is then utilized as the IV for the next block. This is a recurring process for each block. Now this IV, this initialization vector, it's an arbitrary number. It doesn't really matter. And it's also known as a nonce, or NONCE, meaning that it can only be used once in a session. Now how this works is you have the IV here, and then you have the plain text. You scramble them together, and it's encrypted, produces an outcome. I take that outcome, use it for the next block, so on and so forth. Okay? And the way that XOR works is you take one value, and then you take the second value. If they match, then they are going to produce this value, which is a 0. If there's a value of 0 and then the other value is a 1, they don't match, so it's going to equal a 1, so on and so forth. So if I have 0, 0, it's going to equal a 0. If I have 0, 1, it's going to equal a 1. If I have a 1, 0, equals a 1. And 1, 1, since they are the same, equal a 0. Okay. Now continuing on, we have CTM, or counter mode. This is also known as CTR. This method uses a counter instead of an IV. The counter contains additional properties like the initial counter block and a nonce. Both the sender and receiver in this mode need to access a trustworthy counter. This counter will calculate a new shared value each time a ciphertext block is exchanged. It is not essentially a secret value, but both parties must keep the counter synchronized. This mode does not require any padding. So both encryption and decryption in CTR mode are illustrated in this picture. Steps in operation are: you load the initial counter value in the top register, and this is the same for both the sender and the receiver. Encrypt the contents of the counter with the key and place the results in the bottom register. Take the first plain text block P1 and XOR this to the contents of the bottom register. So that's talking about right here. This result is the C1. Send C1 to the receiver and then update the counter. Continue this matter until all the plain text blocks have been encrypted. To decrypt it, we just do the reverse process. Now we have GCM. This model builds on CTM by combining the ciphertext with an authentication code. So now that we have an authentication code, it will provide confidentiality, which is the encryption, along with integrity. Then we have stream versus block ciphers. Stream ciphers utilize something called substitution. It is faster but not as secure as block ciphers. The ciphertext is always the same length as the plaintext that it was encrypted, which makes it less likely for errors to occur. If an error were to occur, it only affects one bit and not the entire string of text. So substitution in this case takes plaintext using the XOR method and completes a one-for-one swap with each bit of information. Now in block ciphers, these are considered more secure, but they take more time to execute. Instead of encrypting a bit at a time, encryption is done in blocks. The block size can be modified, but the most common size is 64 bits. Sometimes plaintext may not take up the required amount of space, so this is where padding is added. This wraps up cipher modes.